Hello and welcome to Vodcast 6.5. This is the final Vodcast for Chapter 6, and in it we will discuss mountain building. The technical term that we'll use for mountain building is orogenesis, and orogenesis is the set of processes that form a mountain belt. One of the most important bullet points in this presentation is the one that you see in red font, and it's important to note that most mountain building will occur along convergent plate boundaries. Our key focus in this video podcast are on the old mountain belts and the young mountain belts shown in this image. Specifically, we will talk about the formation of the Himalayas, the formation of the Andes Mountains, and the formation of our very own Appalachian Mountains. And going forward, just keep in mind that the Himalayas and the Andes are young mountain belts, whereas the Appalachian Mountains are an old mountain belt. Okay, let's talk about subduction in mountain building. And here is an equally important bullet point that you should probably jot down. Subduction of oceanic lithosphere is the driving force for orogenesis. For our first mountain building example, let's talk about alpine mountain building. And we'll consider the Himalayas when we talk about alpine mountain building because they are the perfect example for this mechanism. The Himalayas formed when India and Eurasia collided in a continental-continental collision. Let's study the center image for a minute. In part A, we're looking at the way things looked prior to the collision between India and Eurasia. Now, India and Asia are both associated with continental crust, but as India moved towards Eurasia, there was a subducting oceanic lithosphere on the coast of Eurasia. Water driven from that subducting oceanic plate was triggering melting in the mantle, and there was quite a bit of volcanism occurring on the coast of Eurasia at this time. You have to imagine India creeping closer and closer to Eurasia over a very, very long time period. And eventually, when India smashed into Eurasia, we saw the folding and faulting of crustal rocks that lay along the margins of both continents. This was the birth of the Himalayas. As a second example of subduction in mountain building, let's consider Andean mountain building. And although it's fairly obvious, we're talking specifically about the formation of the Andes Mountains, which run down the west coast of South America. In image A, we're looking at a passive continental margin. And what that basically means is everything shown in the image right now is part of the same plate. However, at some point, plate tectonics does its thing, and the oceanic lithosphere will start to subduct. As was the case in our previous example, water driven from the subducting plate will trigger melting in the mantle. And when that melting occurs, we will see volcanic activity occurring on this coastline. Both compressional forces and igneous activity will continue to further deform and thicken the continental crust. And as this occurs, we'll see the elevating of the mountain belt. And then in the final stage, subduction will slowly grind to a halt, and there will be a period of uplift. But in summary, the Andes mountain building example shows us that a passive continental margin can become active. And once the subduction of oceanic lithosphere begins, we can see mountain building occur. Our final consideration in this podcast, and in Chapter 6, is the formation of the Appalachian Mountains. I see I forgot one of my parentheses, but the Appalachians were generated by orogenes that lasted a few 100 million years. And the formation of the Appalachian Mountains resulted from three distinct stages of mountain building. In the top image shown, we see that there was a lot going on between North America and Africa about 600 million years ago. In between the two, we see a volcanic arc and we see a microcontinent. And notice that the subduction of oceanic lithosphere is driving both volcanic activity and mountain building for the volcanic arc and the microcontinent. In image B, we're going to fast forward to about 450 million years ago. North America has smashed into that volcanic arc, and orogenesis has occurred on the very far east coast of our continent. We still see subduction occurring underneath the microcontinent that's driving volcanic activity. But now if we shift our focus to image C, we see that North America has smashed into the microcontinent, which has triggered further mountain building along our east coast. At this time, which would have been about 350 million years ago, there would have been volcanic activity occurring along the east coast of North America. Now let's take a look at image D, because this was the formation of Pangaea. Finally, after the North American plate smashed into the volcanic arc and the microcontinent, it will now smash into Africa. And when North America smashes into Africa, this is like the Battle of the Titans. The collision of these two continents produces an enormous, breathtaking mountain range that probably would have rivaled the Himalayas at the time. So the birth of our Appalachian Mountains occurred on the interior of Pangaea. In the final image, we see the splitting of Pangaea and the birth of the Atlantic Ocean. That rift that you see forming in the North Atlantic Ocean actually occurred east of where the Appalachian Mountains sat on Pangaea. And what's kind of cool about that is that as Africa and North America separated, North America took part of the African plate with it, and our east coast was once part of the African continent. As mentioned at the beginning of this podcast, the Appalachian Mountains are an old mountain belt, and over time erosion and mass wasting has really rounded them off. But at one time during Earth's history, long, long ago, the Appalachian Mountains would have been the premier mountain range on this planet. Okay, that concludes this video podcast, and that concludes Chapter 6. It's important to keep in mind that the conceptual thread that stretches through Chapter 5 and Chapter 6 is plate tectonics.